It's pretty wild when you stop to think about it. The human body is running one of the most incredible manufacturing processes on the planet, literally 24/7. We're talking about cranking out millions of highly specialized microscopic machines every single day. So today, we're going to dive deep into the fascinating world of spermatogenesis. That's the incredible journey behind creating one of life's most essential vehicles.
So that really is the big question for us today, right? How in the world does the body build a microscopic swimming machine completely from scratch? How do you take just a simple cell and turn it into this complex, self-propelled vehicle designed to deliver genetic information? Well, the answer is actually an incredibly elegant, multi-stage production line.
Okay, so like any good production line, it's got to start somewhere. It starts at the factory. And for our purposes, the factory floor is located inside the testes. It's this highly specialized environment that's pretty much designed for one thing and one thing only: building sperm cells.
All right, let's get into the nitty-gritty. The official name for this whole process is spermatogenesis, and it all goes down inside these really tiny coiled-up tubes called the seminiferous tubules. But here's the kicker. The entire operation, the whole shebang, is kicked into gear and run by the hormone testosterone. Seriously, if there's no testosterone, there's no production. Simple as that.
So we know where it happens and what gets the engine started, but what's actually going on at the cellular level? How do you forge the cell itself? It all comes back to having the right blueprint for turning a really basic cell into that super specialized swimmer we're talking about.
The real magic here, the core of this whole transformation, is a process called meiosis. So, it starts with these cells called diploid germinal epithelial cells. Now, diploid sounds fancy, but just think of it as a cell with a complete, full set of genetic instructions, like having the whole instruction manual. Then, through this amazing process of meiosis, one of these starter cells divides up and it actually halves its genetic material. The result? You get 4 haploid sperm cells, and haploid just means they're carrying half the instruction manual, perfectly ready to go find the other half from an egg.
Okay, so once that basic cell blueprint is created through meiosis, it's time to assemble the final product. And let me tell you, it really is a perfect little machine. It's a biological marvel that's been engineered with just ruthless efficiency for one single critical mission. And what is that one mission? Fertilization. That's it. Every single tiny part of a sperm cell is designed to achieve that one goal. There's no fat, no wasted space, no wasted energy. It's the ultimate specialist, built for one thing. So let's take a look under the hood of this incredible machine. Right at the very tip of the head, you've got the acrosome. Think of this like a chemical drill filled with enzymes designed to dissolve a path into the egg. Then right behind that, you have the nucleus. This is the precious cargo, carrying all of the male's genetic material. The engine room? That's the middle piece. It is just jam-packed with mitochondria, the powerhouses of the cell, and they're just pumping out energy for the big swim. All that energy powers the tail, which is basically the motor, the propulsion system. And get this, it has very little cytoplasm, which is the stuff that fills most cells. This makes the whole thing super lightweight and streamlined, all for maximum speed. But hold on. Just because these little machines are fully assembled doesn't mean they're ready to go. Not yet. They still need to go through a final training and packaging phase, you could say. This is the last stop on the assembly line before they get shipped out. So after being built, the newly minted sperm cells travel to a place called the epididymis. This is kind of like a boot camp and a waiting area all in one. It's here they actually learn how to swim. Then when it's go time, they get launched into a tube called the vas deferens. And this is where they start picking up supplies for the next phase of their journey, mixing with fluids from a few different glands. And this mixing process is what leads to the creation of semen. Yeah, the addition of all these different fluids is what turns a bunch of individual sperm cells into the complete package, the transport medium that's going to help them survive the trip. So what's in this special cocktail? Well, you've got a few key contributors. First up, the seminal vesicles. They add nutrition, basically packing a lunchbox for the sperm for their long journey. Next, the prostate gland adds a fluid that helps with movement, sort of like giving them a performance boost. And last but not least, the Cowper's glands secrete a fluid that's absolutely critical. It neutralizes acid, both in the male urethra and in the vagina, basically clearing the way and making the environment a lot less hostile for the sperm. And there you have it. With all the pieces in place, the fully matured sperm cells and all those protective, nourishing fluids, the final product is complete. You now have millions of sperm suspended in semen, totally equipped and mission-ready. When you step back and look at it, it's just an incredible journey of creation, isn't it?
A masterpiece of biological engineering. And the craziest part is that all of this entire complex manufacturing process has to happen perfectly long before the real journey, the race to the egg, even gets a chance to begin.
It really makes you wonder, doesn't it? I mean, after seeing all the complexity that goes into something so fundamental, you just have to ask yourself, what other microscopic marvels are out there? What other incredible biological production lines are hiding in plain sight, all around us and even inside of us, just waiting for us to take a closer look?